Good morning, everyone, and thank you for joining us today. We are with Wallace, Rowan, and Pierre Trudeau from Positron Access, and are very excited to unveil their newest product, an outdoor GAM product in both 4-port and 8-port options, and available for MIMO or Coax deployments. It's certainly a real game changer. We will also touch on some of their new zero-touch provisioning G1001 End Point CPEs. With connectivity demands skyrocketing, this MDU solution comes at a perfect time. You can now install GAMs at buildings in a matter of hours and ship the G1001 units directly to the end customers for self-install. Projects that were before passed up are now an installation breeze. So please submit all of your questions, and we will cover them after the presentation. I would like to go ahead and hand it over now to Pierre from Positron Access to go over all of the info they prepared for you today. Pierre, the floor is yours.
Thank you, Jonathan. With me, we also have Wallace Rowan, who handles the sales and is, amongst others, responsible for working with ISP. So we'll get you a quick update on G.hn for those of you that are not familiar with the technology and where it compares with some of the other status quo, other options that you may be more familiar with. We'll go quickly over the portfolio of GAM devices, and we'll focus really on our new outdoor GAMs that Jonathan just gave you a quick summary of. And we'll see some use cases on how it gets installed, how it gets used by other operators, and why that is beneficial, and a quick wrap up. So G.hn is really gigabit home networking. And it's an international standard from the ITU, the same way that the DSL standards, the radio standards, GPON that you're probably familiar with. And actually, there's a typo there. In March 2016, ITU-T really extended the application, where initially it was done for lower speeds and really for in-home over power lines, to now really get it to operate over telephone wiring, so Cat3 or better, and coax. So you have some options, and it can push data rates of up to 2 gigabits, which really get about 1.7 gigabit of actual TCP/IP throughput for subscribers. And what is critical is, as it works over the telephone pairs or coax, is that it has a dynamic bandwidth allocation feature, which means that unlike DOCSIS and similar technologies that have a fixed ratio of upstream to downstream, it dynamically adjusts to give you the best bandwidth in the direction that you need in real time. And we made sure that the solution has all of the features to really install in hours, install and activate. I should stress activate as well. It doesn't take days or weeks. And when we run on Twisted Pair, we have this feature called Vector Boost that is used a bit like vectoring over DSL, where it's all about noise cancellation that is inherent to Twisted Pairs, but coupled with a dynamic transmit allocation capability, which means that we only allocate minimum bandwidth to users that are idle, that only need that minimum bandwidth. So the first band is about 100 megabits, and then we can boost to more bandwidth only to those subscribers that need it for the time that they need it. Managing the spectrum that way really helps mitigate crosstalk and give everyone a much better overall experience. So why does G.hn matter? Well, it benefits everyone in the value chain. So if we go from the subscribers, so the renters, in a number of surveys, one, for instance, of 2 years ago from BBC Magazine, they rated access to gigabit internet at the top of their list, above any other amenities. And that was before the current situation with a lot more home working and remote learning, which probably would bump up this number. And MDU owners know this. And what they realize is that the rent value can be as high as 8% more when they are in a gigabit-enabled building. And they can easily offer this to their subscribers. We even see an increase in bulk agreements where it's now part of the rent, because everybody needs to get it, wants to get it. And then for the condo owners, so when we go into these private residential units, they can see the resale value of their condo go up by about 3%. And for you as operators, you can save 60 to 70% capex from going the route of GPON to every door, from going the route of DOCSIS or even G.fast. So the GAM is really in a class of its own. So GAM stands for G.hn, Access Multiplexer. So it's the Ethernet switch device where the ports are now G.hn, so it's Ethernet over twisted pair or coax instead of just your usual optical ports or Cat5 ports. So in terms of cost effectiveness and in terms of being gigabit future-proof, G.hn is really out there. It's better in terms of cost effectiveness compared to DOCSIS 3.0, 3.1, which was kind of the leader up until then, and far more better than G.fast or DOCSIS in terms of the bandwidth. And for the for the bandwidth, it's on par with the GPON. What you can deliver today with GPON, you can achieve the same bandwidth over G.hn. But you don't have the impact of the splits that you see with the GPON, where everybody kind of gets to share the same backhaul. So they're limited to an aggregate maximum of 2.5 gig down and 1.5 gig up. A GAM can handle a lot more traffic, easily 10 gigabits per second that you can allocate across your users. So when you get to a point where you need to push more to the users, just crank up the uplink, the access into the building. The rest is already ready to be handling that. So covered earlier, the dynamic bandwidth allocation, which is critical to really match the demands and allows a lot more upstream than alternative technologies. We also have this device is carrier grade with C2.0 features if you do any kind of business Ethernet functions. And it's easy to integrate with OSS and BSS, but all these don't come at a premium in the cost. It makes it still the unit, the solution is still very much cost effective. So when we present this, a lot of people start to say, well, hold on, I was planning to do fiber to the door. Do I have alternatives? Because now this was causing me to pass on a lot of buildings that were not easy to deploy fiber or fiberize, if there's such a word. So we really focus on brownfield buildings, although we have customers that are even using G.hn on brand new buildings where they feel that maybe the fiber was installed by an alternate carrier that may not want to play ball with them. And as an MD owner or as a smaller regional operator, a WISP, you have some options over the twisted pair or the coax. What is nice is there's no disruption. You don't need to worry about concrete walls and ergonomics and whatever else you may find in these walls. There's no concerns with asbestos and so on. And it's something that the larger operators are all starting to look. We're working with 3 of the top 5 operators in the US and operators also top ones in Canada and Latin America. And you have the ability to stay on top of this and actually even beat them to their game by being a lot more efficient in terms of how quickly you can do all this. When we have the ability to use the coax, then whatever splitters out there for DOCSIS will work for G.hn. So a single G.hn port can serve up to 16 tenants or 16 subscribers. And you don't need to touch anything. It just works seamlessly. It's compatible with satellite-based TV, whether you also resell dish or direct TV. And it also very easy to use IPTV with lots of features to handle multicasting, not just unicasting of TV channels. And what's important is when you offer business Ethernet services, you can have symmetrical service offerings that you present to your customers. GPON is inherently asymmetrical. If you make it symmetrical, that means you just lower the bandwidth to the subscriber. G.hn with this real-time symmetrical capabilities can do the trick. So here's a quick summary of GAM devices. We have indoor units, and what we'll be covering today is the outdoor units on the top right of this slide. So we covered carrier grade, it installs in hours. It's also zero-touch provisioning. And one of the key benefits of these outdoor units is that you don't have to enter the building. In these COVID days, we're getting the okay from the building owners and their tenants to say, we will have this unknown tech you've never seen before enter the building. Sometimes they're a bit queasy. Now you can serve the buildings from the outside in with these outdoor units that don't need local power, that are IP67, so they can withstand any kind of temperature conditions, hot or cold, sleet, snow, rain, whatever you can throw at them and keep on operating. And they support reverse power feeding, which means that the subscriber can provide enough power to turn on their service, not the neighbor. Everyone contributes power, but they can do that very simply and self-install, which means that you don't need to have a tech enter the apartment either. So some examples of how far we can push a gigabit. It's 800 feet inside a building over a twisted pair when we have 2 pairs, a single port still. And on coax, it's 2,600 feet, half a mile. So it gives a lot of flexibility as to how you deliver services. And although we have reverse power feeding, we also obviously can handle local power where available. So if we look at operation over twisted pair, that's probably the most prevalent medium, the easiest one to leverage in buildings. The blue line is when we have a single pair to a subscriber. So you all know about CISO and MIMO being wireless ISPs. G.hn does the same thing. So we can have 1 or 2 pairs. So the blue line is a single pair, and up to about 100 meters, the distance are in meters, so about 300 feet, we present very close to 1.4 gigabit of aggregate bandwidth. And we can balance the bandwidth to be in the utmost or the most aggressive downstream ratio. We can have 80% of that bandwidth downstream, the balance upstream. Or if you want to favor the upstream, we can go to a maximum of 70% upstream and the rest is downstream, or any ratio in between. And that changes based on the actual demand of users. And the red line, what's interesting is when we have 2 pairs to a port, so no pair bonding needed, you don't sacrifice a second port for without adding a number to 1 more subscriber. Every subscriber is 1 port only. But in MIMO mode, the 200 megahertz of spectrum used by G.hn, we split it to be 2 times 100 megahertz. So that means less attenuation due to distance. And we start to see the difference beyond that 300 feet range, more or less, where now we see a lot less attenuation because we're running in the lower spectrum. And that means that where we have 1 gigabit on a single pair at about 500 feet, we do in excess of 800 feet on 2 pairs. The gray line is G.hn Amendment 2, which is what is currently shipping from all of these vendors. And actually some of them are stuck because their chipset supplier went bankrupt and are at stop production. So you're limited in your terms of choices, and G.fast does not work properly on coax, so it's limited to twisted pair. And if you want to go higher bandwidth, you need to do pair bonding, the same way we've been doing with DSL. Those of you that offer DSL, but that means you have to sacrifice 2 ports for a single subscriber. So your cost efficiency of the DSL is half of what it could be. In our case, there's no such penalty. When we go over coax, the green line is RG6. So that's the standard coax you find in most buildings. And you can see the attenuation is next to nothing for the first 400 meters or so, so in excess of 1,000 feet, which means it's a sizable building. And then it tapers off a little bit, but you can still get a gig at 2,600 feet, half a mile. If you end up in a building where you have the lower quality, lower grade RG59 cabling, the type of coax you may find at your local home hardware store, or Best Buy, places like this, that's not good enough for DOCSIS. A lot of the cable operators will say, no, you need to get better cabling. G.hn doesn't care.
Sorry to interrupt. A question just came in for a quick clarification since we're on the topic now. Is that 2,600 feet over RG6 or RG59?
The green line is 2,600 feet on RG6. On RG59, we can push a gigabit at a distance of about 300 meters, which is just shy of 1,000 feet.
Excellent, thank you.
And in both cases, we can use the same DOCSIS splitters. So you can go up to 16 customers per coax segment. When that happens, basically we have a fairness algorithm that makes sure that no one can starve somebody else. A power user on that segment would take all the bandwidth away from the other customers. That's not the case. But we can dynamically allocate more bandwidth in the downstream direction. So for customer number 1 and customer number 2 on the same segment can get more upstream bandwidth depending on what their respective applications or use cases are. So that makes it very efficient to deliver bandwidth. If you go to the maximum split, well, you could guarantee 100 megabit to everyone. If you need to push more bandwidth, you may sometimes consider a lower split count. Most of our customers on coax will use a 1 to 4, 1 to 5 split, which allows them to have a couple of very high-end, high-demand users and serve a number of other ones with more mundane demands in the range of 100 to 200 megabits per second easily. And what is nice is, although the GAM will actually, I should say, although the GAM does enforce bandwidth profiles, which means that you can have customers at different bandwidth levels and they pay accordingly. And the GAM makes sure that everyone gets fair balance or fair access up to the maximum that they are entitled to, but they cannot exceed the maximum. And that gives you a upsell opportunity where if a customer says, I need more bandwidth through your portal, you can say, sure, we will get you from the 100 meg to the 300 meg or whatever is the next package that they want. And through a simple update to the GAM, no local visits, just say now move John Smith in apartment 302 to the 500 meg package, and it takes seconds, and then the customer instantly gets more bandwidth. So we can do that both on coax and on copper twisted pair. So here is a more global view of the products. So on the left, all those products that have RJ45 connectors are for twisted pair. You can have 1 or 2 pairs per port. And when we want coax, so the dash C, so dash M stands for MIMO, and dash C stands for the coax ports. So we have 12 and 24 ports. Now, a few weeks ago, we launched these outdoor GAM devices. So right now we have 4 models, the GAM4 MRX and GAM8 MRX. So dash M is obviously MIMO, R is for reverse power feed, and X is for extended temperature. And then the GAM4 CRX is 4 ports coax, again, reverse power fed and extended temperature. Inside the homes, we have a G1001 device. So here we're showing the G1001 MP. So this one is locally powered, and so is the GAM. So they match the indoor GAMs. And we have the opportunity to carry POTS and G.hn on first port. And then in the back, we have a gigabit Ethernet port. And the center connector is to connect a POTS service. Coax indoors, we have coax in with G.hn, maybe DirecTV dish can also be overlaid on the coax signal. When we have that, the middle coax connector is a splitter that can connect to set-top box. When we go outdoors with this unit, we have a G1001 MR. So the R stands for reverse power feed. It's the injector. So RPF is like power over Ethernet backward. So now it's the end user device that powers the switch instead of the other way around. So this device is slightly larger because of the G1001 MPOC, because it has the circuitry to inject 48 volts on the pair or the coax port and the coax one towards the GAM. We picked 48 volts because if your techs happen to touch the pairs where, well, there is power, there's no concerns, you really feel a bit of a tingle. So no concerns about their health, their well-being, but it's easy also to operate inside over the existing wiring without causing any overheating issues or range issues. We can push power to about, on 2 pairs, to about 1,200, 1,300 feet on the 24 gauge. So you can locate the GAM wherever you need away from the subscriber without having to worry about being able to deliver gigabit speeds. So This device, as you can see from the picture, is ardent. It's IP67. That means that it can be underwater for about 3 feet for easily 24 hours and more without any concerns that there is any kind of water infiltration that would damage the electronics. The reverse power feed option, as I said before, every subscriber must provide power. And the GAM is designed that a single subscriber is enough to turn on the GAM and make sure that that subscriber gets full service. So the G1001 MR or CR are really G.hn bridges, but they also inject the power. So on the worst case is when we have a single copper pair, because that's the one that may carry the lowest amount of current. It's still enough to power the G.hn port serving the subscriber. It powers the main circuitry, so the Ethernet switch at the core of the GAM, and it powers the uplink. And the uplink can be up to 3 watts, so we can have a very powerful fiber optics SFP or SFP+. We can have a GPON ONT that has a lot of the GPON processing inside that SFP device, which tends to draw more power than what is accepted by standard CPEs. And we're ready for 10 gig PON devices that are expected to draw probably 2.5 to 3 watts, depending on the vendor and the distance that you have to cover. So it's already future proof. And all of these GAM devices have a SFP+ port, so up to 10 gig of uplink bandwidth. And also you can use a copper SFP if your radio is close enough that it's not worth installing a little bit of fiber. And what is unique with this solution is we have a daisy chain capability. And I'll cover that a bit later on in the presentation. G.hn, unlike the other technologies, is homogeneous in terms that any end device can connect to any other end device. There are 2 roles in G.hn. One is a domain master. That's usually the GAM, and the G1001 is an endpoint device. But through a configuration setting, we can take a port of the GAM or multiple ports and turn them as endpoint devices so they can connect to another GAM device and create a chain of devices. And we can go up to 8 deep. So we'll cover that in a few more details coming up. And it's really useful when you have environments like garden homes, rows of townhouses, or even for rural America where you don't want to bring or cannot bring fiber to each and every building because of the cost or building constraints or zoning constraints, permitting delays, and all those things. So the 4 and 8 port MIMO solutions, so they're normally powered through reverse powered feed. We have a local 12 volt DC provision, so that is there for the initial provisioning, meaning that when you do the first install, if you want to verify that the uplink is working, you have yet to turn on your first subscriber, but you want to make sure the device is programmed properly, that the uplink is functional. You can use a battery, you can use the accessory jack of the technician's truck, and give it temporary powering over at 12 volt DC. We will add to the list very shortly, within the next couple of weeks, a version that also supports local 12 volt input with an ECDC power adapter. That is useful for cases where the unit is outdoors or could be indoors, but there is a local power source. So we don't need to worry about reverse power feeding. You can leverage an existing power source. Reverse power feed is for those areas where there's no local power and it is complex, expensive, worrisome to, or the building owner doesn't want to provide the power to begin with, and then you can deal with it with reverse power feed. And they're all extended temperature, so minus 40 C to plus 65. So whether you're in Alaska or Arizona, you can deploy the GAM without any concerns. So if we open the cover, this is an installation where the GAM is connected to an active Ethernet feed. This one was a 10 gig SFP. So you can use a fiber spool, and the customer for that installation had a fiber patch cord connecting into the SFP module. We have two management ports. The top one is serial. The bottom one is gigabit Ethernet. Just above that, we see the 12-volt DC connector just above these connectors. So that's good when you have this temporary local power source, or go straight with the local power option. And then, so this opening here is for fiber. On the left is the opening for copper. And then you have punch-down blocks, so you can assign 1 or 2 pairs for each of the ports. And the main circuitry of the GAM is on the right inside this device, and in the cover we have the reverse power feed circuitry. So you patch the pairs here. They have G.hn and power. We extract the power, bring it here. It puts all the signatures, as usual stuff done for the same as power over Ethernet, and then it generates the power signal for the main motherboard. And this is where we control whether we have power on the port or not. Because again, you need to provide power to a port to get granted service. So no free ride by customers that try to let their neighbors pay for their little bit of power. There's not much needed there. The Coax version is very much the same, except that we have 4 or 8 Coax ports. And the dimensions are small, so this is about 8 inches wide, 12 inches high, and about 3 inches deep. It comes with a mounting bracket that makes it easy to apply on the wall, so a flat surface, or instead of a pedestal. It can also easily be attached to a pole and can even be strand mounted if you don't want to pay pole attachment fees. Here's a simple diagram of how you have your uplink, whether it's optical or fixed wireless. Connect to the GAM, and the GAM here has copper pairs to each of the households. At the other element is that in the head end, or the NOC, we install VIRTUOSO. VIRTUOSO is a software tool. It's an element management software from Positron that runs on a Linux server with the hardware of your choice. Just a regular PC will do. It is offered as a Docker image running on a VM, and we'll show you quickly how that looks like. So whenever the GAM is first activated, it calls home to VIRTUOSO to get its working configuration. If there's a if there is a firmware update that you had approved, started to deploy your network, but this unit was on the shelf and didn't get updated, it will get updated automatically, and then it's ready to function. And then there's a regular keep alive from the device to VIRTUOSO to say, hey, I'm here. Do you have any changes in the new configuration for me? But VIRTUOSO is never in the data path, so it doesn't slow down any kind of net bandwidth you offer to your subscribers. The Coax device is very similar, same operating characteristics, same powering options. The only difference is we have, in this case, 4 F-type connectors. So you can attach the side of the building and really replace where you would have the feeder cable from the cable operator with a patch that then allows them to serve the customers inside the building over Coax. You just remove that with a tap, not a patch, and then you just attach to the Coax here. If you have multiple Coax going out, also on the edge or the back of the building, you can put outdoor splitters if you want, or if the splitters are inside, if the splitters are installed inside the building, then also you just need to connect the Coax straight into this device. And on the right, we have again the same fiber connection port that actually can also be used if you have a copper feed. Here we have a good view of the grounded log, and we have even a vent to make sure that there's no moisture buildup, nothing that can damage the device. The diagram is very similar to the first one I showed. So the same broadband 1 to 10 gig transport. The GAM is reverse powered, but what is different here is if we have a splitter, let's say we have a 1 to 4 splitter, so we can cover these 4 apartments on one feed. They all contribute to power. So although I have a first Coax subscriber on that port, on the first port of the G.hn of the GAM, adding a second subscriber, unless that the subscriber provides power, it will not be allowed to bring up the link. So everybody needs to contribute their share of power. So when we have multiple subscribers over a Coax port, they all contribute evenly. That's not the first one that does 60% and the other ones do 20% each. everybody contributes the same way. And then we have another splitter, and we can keep going like this, either up or lateral, depending on the nature of the building. So with a 4-port Coax GAM outdoors, at the maximum split, you can serve an MD of 64 doors. So that gives you a very low investment, much less than what the DOCSIS guys have to install and operate. No amplifiers. G.hn does not need amplifiers to achieve that gigabit speeds at 2600 feet of RG6. So very easy, very cost effective to install, and very little maintenance. Now we have the G1001 MR and CR. We'll show you a quick picture there. So let's focus on them. The MR, so MIMO and reverse power feed. All you need is you have a wall adapter. It's AC/DC device that brings 12 volts to the MR. It injects the power over the 1 or 2 pairs towards the GAM, and in the back you have the gigabit port. What is important to know is when we inject power on G.hn, it does not impact the reach. It has no bearings on how far you can go or how well the signal is. There's no noise being induced or anything of that. When we do coax, again, G.hn on the rightmost connector, we have the splitter. We always put a coax splitter because we have a lot of customers that want to go with Dark TV or dish, so that's very convenient. When you do G1001 with reverse power feed on copper, it will not work with POTS pairs because you have 48 volt for the POTS servers that would kind of go in the opposite direction of the G.hn power. We're looking at adding a mode where in MIMO we could have 1 pair for power and the other pair would be for POTS, so the 48 volts would be independent from one another, and then we could have both coming up. So this is something we're looking at adding probably by the end of this year or beginning of the Q1. Then the back of the device is the same for both cases. So we have the gigabit port and a number of status LEDs that you know that the link is up, that the power source is working fine, that there is no short issues, anything that would prevent the power from reaching the GAM device. So now the daisy chain configuration. Normally, a lot of GPON operators would like to put a fiber at the entry point into, say, a garden-style neighborhood, and then use a passive splitter and then bring fiber to each and every door. A lot of homeowners association are, although they want to get more bandwidth, they're not crazy about having sidewalks or the street broken or their fence and landscaping, and they resist all of this disruption. So a lot of our customers that have access, the larger operators typically, but it's also available to some of the smaller operators, depending on who owns the copper plant inside that gated community very often. You can bring fiber to a first drop-off point or fixed wireless, your 1 to 10 gigabit, and then through this daisy chain mode, you're able to now stretch how far you can push the signal and still serve clusters of up to about 40 ohms when you go 8 devices deep. And reusing the copper plant is very efficient. We are working to add this capability over coax as well. And we use an alternate power source for the GAM devices in the chain, simply because with reverse power feed, you don't want to see a situation where a mid node in the chain may not be serving anyone else. You serve all the homes upstream and plenty of homes downstream from that point on. But for whatever reason, at this point in time, you don't yet have some customers in that around that cluster of homes where a mid node is installed. So we use a well-known power source over copper known RFTV. So it comes from 2 main vendors, GE or Alpha, that both cater to the telecom operators. It's plus or minus 190 volts, so you need to be a little bit careful of how you deal with the technology, but it's been around for 20 plus years, so people know how to deal with it, and it can bring the power to these intermediate nodes. So if we look at the diagram, on the far left, we have the same GAM devices we saw earlier. So a 1 to 10 gig input, fiber or fixed wireless. Each GAM having 8 ports. We use 2 ports to create a link aggregation chain to the next device. We could do 3 ports if you need more bandwidth. 2 ports is nice because it gives you a minimum of 2 gigabits of speed. And we see that these other nodes usually follow where the telco pedestals are installed, and they tend to be spread apart every 300 feet or so, although in some cases we can see 600 to 800 feet, depending on the density of the homes that you need to serve. So even at 800 feet, we still have this 2 gigabit of traffic that goes out. So first device having 8 G.hn port, 2 are serving the chain, so we can serve 6 ohms nearby over copper. When you go to these mid nodes, they have 2 ports for the uplink from the node, 2 ports to continue the chain downstream. So we're left with 4 ports that can serve the ohms, and we keep going like this. And the last one in the chain can, again, because it only uses 2 HN ports to terminate that chain, it can serve 6 ohms. And you'll notice that the rightmost one has a fiber or SFP plug. The other ones have, from the left, those are the copper pairs going to the home. Then the copper pairs for the uplink, the copper pairs for the downlink, and then the last port is used for power, so that we can power each of these devices, independent of whether they are currently serving active customers or not. Because you may light up the neighborhood and you have everyone signs up very quickly, but this number 3 in the chain here, for whatever reason, no one has signed up yet. No worries, they're all powered, independent, and that means that inside the homes you use our standard G1001 devices. You don't need to use the ones that are reverse power fed. So the last thing I wanted to cover was VIRTUOSO. So VIRTUOSO is like a domain manager or domain controller, the same way you have maybe for the OLTs or your radios, your aggregation routers. And it has an open API based on JSON. So the GAM will manage the GAM devices that get discovered and get their updates and so on. But this JSON API is also available to you if you want to use your own platform for these functions. So we have a number of customers that add a platform, a lot of them using JSON to talk to some other devices, and they're just adding this. It's a very quick addition, very easy to do. We have plenty of documentation and examples on how to do this. And for when you're ready to go SDN, which I understand is still probably a work in progress, we'll be adding next year a YANG and NetConf northbound interface so that it's easy to interface with these lifecycle service orchestration platforms. So if you look at VIRTUOSO, right now we're just about to launch the first version that is a free version, so no licenses needed to install this on your server. And you see, for instance, out of the systems, this was a snapshot, took a while ago, actually that's June, of our lab installation. You see serial numbers, you see the model number of the device. The IP address, what is interesting is when you click here, it opens up another page straight to the web GUI of the GAM device. We can group them together logically. They don't need to be even the same model of GAM. So we have a mix in this example of Coax and MIMO GAMs that maybe you want to group them together because you want to make sure that they all get their firmware updates at the same time. If we have a setup with multiple GAMs into the building for larger properties, we can also virtualize them that they all appear to be one and only device from a reporting view. So you see a number of endpoint devices, subscribers, bandwidth profiles. So you can push multiple bandwidth profiles and then assign users to whichever profiles they want to sign up for. And you can see the firmware revision and you can update this if needed. And then if I click on seeing the subscribers, then we see that we have 4 subscribers in this example. The endpoint device that is serving them, in this case, this one, we were just it was an example where it was bulk internet, everyone gets the same speed, unthrottled, and VLAN management. So the GAM can do single or double VLAN tagging, can do VLAN tag replacements. We can also, we have full QoS at level 2, layer 2 and layer 3. So you can do rate policing and bandwidth shaping as you see fit. We can prioritize traffic that kind of suffer from latency like voice over IP and so on. So with this, the GAM really provides an unfair advantage to those operators that are deploying this. And we're starting to see this where we have customers that were in competing scenarios against the incumbent, and they were able to bring very aggressive pricing, still maintaining very healthy margins, and beat the tier ones to the punch. It installs in hours. Usually 2 hours is all you need to install a GAM device, and with practice, you can probably get it done in about 1 hour. And since we have flexible bandwidth packages, you can really fit the needs of your subscribers and gives you an upsell potential if need be. So usually people say, well, hold on. I thought I had all this figured out. I knew how to address MDUs and MTUs. Now you're telling me that things can be different? So yeah. Usually, although you got it figured out, doesn't mean you have the answers you would like to have in terms of the cost. How much you need to invest per ohms fast and ohms activated. If you do fiber to every door, you need to pre-wire everyone, although they may never sign up because it's too costly to go back at it a few times. So you want to make sure that your costs are very competitive. And the speeds, can you really bump up the speed? Although your customers say, sure, I'm fine with 100 meg now. You know that eventually they'll need more bandwidth. And how complex is your installation? If you're considering fiber to every door or a DAS system to extend your wireless service, you say, hold on, this is a lot of work. So think again. And when do you have to go back at this? Because what kind of equipment do you need to change and to handle maybe more IPTV, more gaming, more IoT, and all that? With G.hn, you can really get control of your strategy. The cost is very low, both ohms fast and ohms activated. The speeds is not an issue. We can deal with the gigabit speeds. In terms of implementation complexity, well, you use the existing wiring. So the worst thing that can happen is that the wiring is not properly labeled. So that's easy to sort out, and then you're good to go. And I'll say it's good to last. You can start with 1 gig to the building now, and when the time comes, you can easily go to 10 gig or even 20 gig. The larger GAMs have 2 10 gig ports, which we can aggregate. So you can push a lot of bandwidth to the building before you run out, before the GAM cannot keep up with it. And that means you can really increase your revenues quickly and with a very fast payback. So with this GAM, you can address a new challenge. You deliver the services that the telecommuters, the home workers, the remote learners need today, no matter what the size of the MDU, no matter whether it's a brownfield MDU. And we always we have a cost calculator that we're just about to launch later this week that will help do some cost comparisons with other technologies, and you can input your costs, and that will just show how cost effective the GAM really is. And it's a fiber extension and fixed wireless extension technology. We're not competing with the access piece. With fixed wireless or fiber, it's not the role of G.hn. G.hn is really taking these gigabit services and deliver the last few hundred feet to 1,000 feet to these townhouses, garden home units, and small MDUs that are otherwise not really cost effective to cover. So you can be the hero, and your customer will really thank you for this. And maybe if I do a quick wrap, this is our last slide, and then we'll have enough time for the Q&A. I recently wrote an article in the Broadband Community magazine, I think that came out yesterday. And we have an article covering this, and we see 4 steps to really benefit from these outdoor GAMs. First is use the existing wiring so you can lower your construction, actually avoid the construction cost altogether and no disruption. The only disruption is to your competitors that cannot keep up with you, and serve the building from the outside in. Don't have to worry about entering the building. By leveraging reverse power feed means that you don't worry about getting permission or getting someone to install power where you need to install the GAM. Just install the GAM where it belongs, next to wherever you terminate your fixed wireless radio or your fiber feed. It can be by the curb, up on a pole. As long as you have access to the in-building wiring, from there, you're good to go. And then ship the G1001 to your subscribers. You can create a captive portal, let customers sign up, and then send the G1001 that can be pre-provisioned easily in two, three quick clicks on the management platform of the GAM, and let the customers activate themselves, do the self-install, so no new truck rolls, and you're good to go. So on this, Jonathan, I'm through. This is the last slide, and we can start taking questions from the attendees. And we
Excellent.
have a free try and buy program, and Jonathan and Wally can definitely help you take advantage of it.
Excellent. Thank you, Pierre, for that really good presentation. And yes, we did have quite a few questions, Rowan. One of them is, for the Coax GAM, what is a good number of splits for each GAM port?
So as I said earlier, we can go to 16, but let's take an example. Most of our customers go 4 to 5 splits. So we have 1.7 gigabits. Let's say that you do a 1 to 4 split. You could guarantee, say, 200 meg to everyone aggregate. That would leave you a gig that you can burst to any user that need more bandwidth, again, in upstream or downstream. And that means that you could push a gig service to 4 subscribers, with the understanding that on average, there's only 1 out of 4 that needs a gig at any point in time. But over an hour, over a day, they all have access to the gig when they need it. And very often, you'll see that your uplink becomes a bottleneck, not the distribution inside the building.
Okay, thank you for that. Also, for the reverse power feed to the GAM, how many endpoint devices are required to power the GAM?
So just one is enough. And if you do it over twisted pair, even if you have a Cat3 wiring, one pair is enough to power the GAM. And as I explained before, it's bring your own power approach. So if you're the first customer, you will only power that one G.hn port of the GAM. The other ones are powered off. And then you power the main circuitry and the uplink. When your neighbor turns on, then that neighbor will power his G.hn port, but you will evenly, the two subscriber will evenly power the main circuitry and the uplink and so on.
Great, thank you. Another one is, the daisy chain capability is unique, but help me better understand the golden application and what GAM equipment is needed. Also, is that different than the RPF GAM?
So the first GAM could actually, even I would recommend that each of them are powered independently from the subscriber. The reason for this is, in a G.hn situation, you don't want a middle node in the chain to be powered off because you're not actively serving a subscriber at that point in time. So that's why we, over twisted pair, we will use the RFT-V technology, so plus or minus 190 volt. And what we do is we usually bring 2 power pairs to each device, not because we need 2 pairs, but just for redundancy. And a group of 3 power pairs can serve 3 GAMs, where we have pair 1 and 2 on the first GAM, pair 2 and 3 on the second GAM, and pair 1 and 3 on the last one. And if we lose any of these power pairs, everything keeps going as usual.
Thank you. Can you define multiple bandwidth profiles for subscribers on the same unit, the same GAM unit?
Absolutely. We can support up to 16 profiles that are active, and we're going to increase the number of profiles that can be defined in an upcoming release. So you could have subscribers that may have 100 meg, and some on the 200 meg, some on the 500 meg, some on gigabit speeds. And those profiles may be symmetrical or asymmetrical. It's really up to you. You decide how you want to offer different tiers of bandwidth.
Great. Can we offer an IPTV service through the GAM?
Absolutely. And we have a number of operators that do this. The GAM supports IGMP, and the GAM supports also multi-VLAN registration for multicasting. So we have, in this case, a lot of the IPTV content is unicast. That's your HBO and Showcase and so on. But the local TV programming, so the nearby original ABC, Fox, NBC, CBS, and so on, can be provided over multicasting, and the rest is unicast for when you have pause and rewind capabilities and so on. If you want to offer pause and rewind for your local stations, then you need to go unicast. And we have some partners that have developed some really neat IPTV platforms, and we'd be happy to make some introductions if you don't already have a good platform for your service.
Thank you, Pierre. In coax mode, do you support satellite TV?
Yes, we do. We can do either direct TV or dish. And the way this is done is the output of the SWIM, so the single wire modules that feed one subscriber at a time. We take the output of that, we take a G.hn feed that may have already gone through splitters, and then we use a standard diplexer. So one leg is the satellite feed, the other leg is G.hn. It comes out on a single coax that enters the building. And then we use a G1001 C or CR endpoint device that has these two coax ports. So the first one is G.hn plus satellite TV. We extract G.hn output on the GIGI port at the other of the device, and the satellite TV feed goes through the set-top box. And in that case, we can either use lower frequency ranges, which is around 3.5 gig for dish or direct TV to control the SWIM, or some older ones may use voltage to signal changing channels, and that will work also because the G1001C or CR is not a DC blocking switch. It can withstand having the voltage on the coax without any issues, and so is the GAM. So you can work with both type of SWIM technologies.
Thank you. And we do have time for a few more questions here. Is there a cost for the software license for the VIRTUOSO management platform?
Right. So the base one that we're just about to introduce that provides extensive monitoring capabilities and will auto-discover GAM devices, and where we can push a golden configuration. So although you have all the GAMs configured pretty much the same way with the same profiles and so on, usually we see that the IP address for management, the system ID for SNMP, and if you do the HTTP option 82, you want to put a different system name per GAM per building. So there's probably 10, 12 unique parameters that you need to change from the default settings of the main configuration. So the GAM does all of that, and that's a free license. Later next year, we will have a GAM with extensive provisioning, where you could maybe say you want to create a new subscriber, or sorry, a new bandwidth profile, and you want to push it to all the GAMs. Then VIRTUOSO will do that. That will have a minimal license fee, nothing that would cause you to worry, and it's only to help us just keep on supporting the VIRTUOSO lineup with more and more features. But the base one, which is more than enough for most of our customers, will be free of charge.
Perfect. And do you offer a solution for subscriber management and billing?
We have partners that have developed some really interesting solutions working alongside the GAM, and the fact that the GAM can force new, unregistered subscribers to go through a captive portal experience where they can pick and choose the profile, the bandwidth profile, enter their credentials, their credit card information, and then activate the service. So we do that with even some very large tier 1 operators and with some smaller operators. So we would be happy to put you in touch with our partner that does this back-end customer support, customer portal capabilities.
Great. And the last question actually ties into the last slide here, is do you have a trial program for the GAM?
We do. We've been doing this for all of our products for several years now, and it's very well liked by our customers, and it works well. You can go to the link shown here, or you can ask help from ISP or from Wally, and basically you get access to a GAM with a few endpointed device, so whether the MIMO configuration or the Coax configuration, and you get it for 30 days where you can try it in your lab, or in even better, we encourage you to put it into a live property. Maybe you have some friendly customers, and you can really see it in action, get to appreciate how you can manage it, take advantage of it. And we have a support program where we usually hold your hand a little bit, work with you to turn on the first install, make sure everything goes smooth, provide some knowledge transfer. And don't worry, if you need 45 days, as long as you're actively using it, we're not the ones that will send you an invoice after 30 days. And although we ship them from the Positron inventory in our headquarters in Montreal, Canada, we work with our partners, so with ISP, that would then be happy to provide you your pricing, and we'll be invoicing you so that you don't have to worry about credit card being provided to Positron or credit checks and so on. We trust you, we trust our ISP to say, yeah, this is a good customer, and then we'll work with you to make this a success.
And Pierre, one other thing, since you mentioned Montreal, this is Wally, by the way, might want to mention to the audience our Canadian-made, Canadian-built, Canadian-designed content.
Yeah, this is a good point, Wally. I always take it for granted. We're not a Chinese reseller. The product is entirely designed, hardware and software, inside our Montreal headquarters, and we use contract manufacturers in Canada, about an hour from our office, that do the board assembly, and we do the final QA check. We can ship over the border there's no duty applicable to the product, so no worries there. And we work with ISP that keep a stock of GAMs on hand, so they can really expedite those deliveries to you, because although it should never happen, you may need it at the last minute. So they're there, and we work with ISP to also maintain adequate stock with them. But in some cases, we can do drop ship on their behalf, depending on what the need is and the timing of getting it in your hands quickly and efficiently.
That's right. We will not only carry stock here at our College Station, Texas location, but also at our ISP Supplies Canada location up in Ottawa. So definitely let us know of any equipment needs. And thank you very much, Pierre and Wally. That concludes all of our questions that we received. If any more questions come up, please email them in to sales@ispsupplies.com. We will also be uploading this webinar onto our YouTube channel as well as social media, so please make sure to subscribe to youtube.com/ISP Supplies and follow us on facebook.com/ISP Supplies. Thank you, everybody, for attending today's webinar. A special thank you to Pierre Trudeau for today's discussion and presentation, and to Wallace Rowan also for attending and for helping put everything together. And please email us at sales@ispsupplies.com or call us at 855-947-7776 with any additional questions and to purchase any type of Positron equipment. So have a great rest of your week, everyone, and God bless.
Thank you. Thank you very much.
Thank you for setting this up.